All right, so this will kind of explain that last problem on the worksheet. It's kind of tricky, and I'll kind of walk you through the process. And then next week we will also be doing kind of a basic lab activity that I'll have to do for you, but then you'll do the calculations on. So basically what we've got is we've got this kid, and we know his mass, but we don't know his velocity. And he runs and he jumps on this tire swing. Mass of the tire swing is given, and the length of the center of the mass is given. So we know that when he jumps onto that tire swing, there's that collision, and this would be an inelastic collision. So now we know that from this point to this point, that energy is not conserved. So we can't just say that the kinetic energy here is going to be transferred to here and then swings up as the GPE. So we have to use momentum to cross that threshold of that collision. Now once he jumps on there, we know that there's a new combined mass, as it's a inelastic collision. They stick together, so it's that one new mass that has an initial velocity immediately after that collision, and we're going to call that v prime here. And then that velocity is going to start swinging it forward, and it goes up, and at that point it stops. So all of the kinetic energy it had right here becomes GPE here when it's gone up a certain height. So basically what we're going to do is you walk it backwards. So if we're given the angle that it gets to, and that's given in the problem, it's 35.5 degrees, we can figure out how high above the initial position this kid's gone and how much GPE there is. So just by using a little bit of trig here, we know that the length of this is still 7.5 meters. We're given the angle. So to find this vertical distance here, I'm going to just call it y. That would be the 7.5 times the cosine of the angle. So we know that the length from this point to this point is 6.11 meters. So if we want to know how high this kid has gone up, we know that it's the difference between the 7.5 and the 6.11. So we know that he's 1.39 meters above the ground. Now, if we know that he's 1.39 meters above the ground, we know how much GPE that this kid has. So the GPE here came from the kinetic energy here after the collision. So we know that we can set that up as 1/2 mv squared equals mgh, cancel mass, solve for velocity, and we know that v prime, the velocity that this kid and the tire swing together had immediately after the collision is 5.22 meters per second. So then we can use conservation of momentum to cross that barrier of the collision where energy can't transfer. So we know that the initial momentum was all in the boy as he was running. After the collision, the momentum is combined between the boy and the tire swing. So we know that the mass of the boy is given as 35 kilograms times the initial velocity. Afterwards, we've got the combined mass of 43.5 kilograms times v prime, which we determined was 5.22 meters per second. And then you can solve for the original velocity as 6.49 meters per second, and you can ignore my blood marks from my extreme physics scene.